Life is a polynomial equation with leading exponent as positive infinity. So you will never run out of solutions. So today we begin chapter 2, polynomials. We will complete exercise 2.1 in this video. The link to exercise 2.2 and 2.3 is in the description box. So let's start. What are polynomials? Hi, I hope you have pressed the subscribe button and the bell icon. Let's start with what are polynomials. Polynomials are algebraic expressions with some constants a, some variables x, some other constant b, and there can be another variables also, right? And so on. Now this looks a little complicated. So as you know it, certain examples can be just as simple as x plus 2 or 5x square plus 3x minus 1. Now how do you recognize a polynomial? The power of x has to be a whole number. That is how you recognize a polynomial. So in a polynomial, you do not have terms like 1 by x or root x, because in this case, power is minus 1. Another case, power is 1 by 2. Not allowed in a polynomial. So we are done with what are polynomials, how they can be recognized. The next thing is the type of polynomials. You've done that also earlier. Type of polynomials. If polynomial has only one term, it's called a monomial. If it has two terms, it's called a binomial. If there are three terms, it's called a trinomial. The word poly actually means many terms. The word poly means many. Then next concept, very important concept, is the degree of polynomial. Now degree of polynomial means the highest power of the variable, highest whole power. Remember, fractions are not allowed. So degree of polynomial, if the highest power is just 1, like it was here in x plus 2, it is called a linear polynomial. If the degree is 2, that is the highest power, like I gave you this example here, then it is called a quadratic polynomial. And if the degree is 3, then it is called a cubic polynomial. And so on. Next important concept is zeros of a polynomial. This also you've done in class 9. Just a quick reminder, zeros of a polynomial. Now polynomial is usually represented as px or qx or gx. That means a function is in x. I can even write it as py or qy or gy, right? That means the given expression is in that variable. Now px, if is one of the polynomial, that value of x which makes px equal to 0 is called the zero of a polynomial. Like if px is given equals to x minus 2. So if I put x equals to plus 2, the entire px will become 0. So x equals to 2 is a 0 of px, because that value when substituted put in the px becomes 0. You've already done how to find zeros of a polynomial. One more thing here, as many degree, like a linear polynomial will have only one zero, and a quadratic polynomial will have two zeros, and a cubic polynomial will have three zeros. So looking at the expression, you should know how many zeros does that polynomial has. Now, why do we need to know the polynomials? Let's look at the geometric meaning of zeros of a polynomial. We will understand this with the help of graph. Like if this is your x-axis and y-axis, and a linear polynomial like x plus 2 or 5x plus 2 or anything like that will be a straight line, right? The inclination may differ, like this line could be from here to here, or the line could also be somewhere from here to here, right? So a linear polynomial will always have a straight line graph. It will be a line graph. Now, what does zero mean? Zero here implies this point when the graph touches the x-axis. That is the point where we call the zero of the polynomial. Like in the previous question, which I just discussed, x minus 2, it was px equals to x minus 2. So you said that x equals to 0 is the 0 of px. If x equals to 2 is 0 of the px, and this is where I plotted it. So this point will be x equals to 2. The 0 tells that this is the point where the graph or the line is touching the x-axis. Similarly, if I give you x square minus 4, now this is a quadratic. And how will you draw the graph for this one? So we will draw another x-axis and y-axis, and now if I draw the parabola, it will go like this. So you know it is x square, right? And if you find the roots here, x can be plus 2 and x can be minus 2, because in both the cases px will become 0. So when you plot that here, px, that means it is touching the x-axis at 2 points. This is x equals to 2 and this is x equals to minus 2. Let's look at for a cubic. For cubic, usually the graph goes like this. So now if you see here, there are 3 points, one here, and one here. That means for a cubic polynomial, if you draw the graph, it will touch the x-axis 3 times. There are 3 zeros. Now this is the case when I am saying that the expression is given in x square minus 4, x square minus 2. It is only possible then. Now if I change and I give you y square minus 4, if I give you y square minus 4, now this time your graph will not touch x-axis 2 times, but it will touch y-axis 2 times. Once at plus 2, other at minus 2. Let's apply this to the exercise. Exercise 2.1, the graphs of y equals to px are given for some polynomials, and we have to find the number of zeros. The number of zeros are equal to the number of times the graph will touch the x-axis. So in the first one, if you see, the graph is not at all touching the x-axis. So there are 0 zeros. It's not that the 0 is a 0. There are no zeros. Then second one, if you see, it is only touching once. So here the number of zeros is only 1. Then here if you see, this is 1, 2 and 3. This is 3 times it is touching the x-axis. So there are 3 zeros. Then here if you see, this is 1 and 2. It is 2 times touching the x-axis. 1, 2, 3, 4. 4 times it is touching the x-axis. And here 1, 2 and 3. 3 times it is touching the x-axis. So this is how you find the number of zeros by looking at the graph.